All right, guys, in this one, we're going to be solving nonlinear inequalities. Specifically for this video, it's going to be quadratic inequalities, okay? So, in part, you're going to solve these just like we would quadratic equations, but then there's an additional step or steps that we add on the end, okay? So let's kind of break these things down. First off, if a product or quotient has an even number of negative factors, then the value is going to be positive. That's important to know here. If a product or quotient has an odd number of negative factors, then that value will be negative. Okay, this is going to be extremely important when we're doing part 4 of these guidelines for solving nonlinear inequalities. Okay. First thing we want to do, we want to get everything on one side. Move all the terms to one side. So it'll be greater than 0 or less than 0 or whatever the case may be. But we want all the algebraic terms on one side, okay? Now, again, in this video, we're talking specifically about quadratic inequalities. But in the subsequent videos, the video or two that follows, if the non-zero side has quotients and like rational expressions with the variables in the denominator, then we're going to get a common denominator. In this video, we're going to have quadratics. So we won't have any quotients to deal with, all right? If we can factor, we have to factor in order to find the solutions of what would be the quadratic equation, okay, or called the zeros, all right? Then we're going to determine intervals, okay? Because we're solving inequalities, we're going to have ranges of answers that will be considered solutions, all right? And we're going to have to determine the possible intervals that could be solutions, and then we're going to test those, okay? The intervals will be based on what makes this quadratic zero, okay, or what the solutions would be if this were an equation, okay? Once we have our intervals, we're going to make a table, okay, and then we're going to test values within each of those factors, okay, and that'll make more sense as we go along here. This is going to be a video you probably need to watch a couple times to truly get what's going on, okay? Once we make this table, we're going to determine the ranges, okay, or the intervals that actually work for the inequality, and that will be our solution, okay? So we're going to determine the solution of the inequality from the last row of our table, okay? And again, watch this video a few times because I think you're going to need to. All right. In the example problem we're going to work here, we've got a quadratic that is set less than or equal to 0. Okay, so step 1's already done for us. Everything's already on one side. In this case, it's set less than or equal to 0. Okay, this can be factored. So we're going to go ahead and do step 2. We can factor this. If you can't factor this, you can still use the quadratic formula to find the zeros that will help you determine your intervals. Okay. If you could use the square root method, you could do that to find the zeros that will establish our intervals. But here we can factor, so let's go ahead and do that, okay? So x squared minus 5x plus 6 can be factored as x minus 2, x minus 3, okay? So I need to ask myself, what makes this factor 0 and what makes this factor 0, all right? So 2 is going to make this factor 0, and 3 is going to make that factor 0. Okay, these are going to allow me to set up my intervals, okay? So we want to start with the smaller of the two values that make these 0, okay? So 2 is smaller than 3. So I'm going to go all the way back to negative infinity. So my first interval is going to start at negative infinity, and it's going to come up to my smaller 0 here. And again, 2 is a 0 of this. So my first interval is going to be from negative infinity to positive 2, okay? The next interval is going to be from that 2 to the next value, or the next 0. Okay, so my next interval is going to be from 2 to 3, and then my final interval for this one is going to be from 3 all the way up to positive infinity. Okay, so I've done step 3. I've found my intervals. Start at negative infinity, go to the smallest 0, and then the interval between these two zeros, and then the interval from positive 3 to positive infinity. Okay, so these are the intervals that I need to set up. So when I'm setting up my table, I'm going to have my intervals here. Okay, so I'm going to make my table or my diagram. Now what I want to do is I want to determine the sign of any value that falls in this interval for each of these factors. So my first factor was x minus 2. Okay, My second factor was x minus 3, and then I want to determine the sign of the product of these two factors, x minus 2, x minus 3. Okay, so what I'm going to do, I'm going to pick a number that's in this interval. Okay, a number that's in this interval is 0. It's very easy to work with. Okay, so I'm going to plug in 0 to this factor, and I get 0 minus 2. Well, that's a negative. Whether it's what the value is irrelevant. We're just worried about the sign of the value. Okay, so when I plug in 0 here, I get negative 2. If I plug in any other number that's in this interval, I'm going to get a negative value. And again, the value is irrelevant. Okay? A number between 2 and 3, so like 2.5. Let's say 2.5. So if I plug in 2.5 here, 2.5 minus 2 is 0.5. Again, value is irrelevant. The main thing is it's positive. And if I plug in any value within this interval, 3 to infinity, let's say 10, well, 10 minus 2 is positive. Okay, so all I'm concerned with here is the sign of the value that occurs when I plug a value from this interval into this factor. Okay, now let's plug in a value from this interval for x minus 3. Let's use 0 again. 0 minus 3 is going to be negative. Okay, let's plug in 2.5 again. 2.5 minus 3 is also going to be negative. Okay, and then let's plug in 10 again like we did here. 10 minus 3 is positive. Okay, so now then, in this interval, this factor is negative. In this interval, this factor is negative. So again, values are irrelevant. If I've got a negative times a negative, then I'm going to get a positive value. Okay, so notice, from this interval, from negative infinity to positive 2, I get a positive value. Well, that's not what I want. My inequality here says it has to be less than 0, which means it's negative. So this interval is not part of my solution set. Okay? If I multiply a positive times a negative here, this is going to be negative. Okay? That's what I want. So this is going to be part of my solution set, this interval from 2 to 3. And then finally, a positive times a positive is going to be positive. Okay, that's not what I want. My inequality symbol says I need a number that's less than 0, so negative. So then that tells me this is the only interval that is a solution of this quadratic inequality. Okay, so I'm not all the way done yet though, because these intervals 2 to 3, I needed to know, does 2 count as part of the solution, and does 3 count as part of the solution? Okay, so in this case, my answer is going to be the interval from 2 to 3 inclusive. It includes 2 and it includes 3 because my inequality symbol has the or equal to part. So if I plug in 2, I get exactly 0. If I plug in 3 here to this original quadratic, I get exactly 0. Okay, so 2 and 3 both need to be included in my solution. Okay, what I would do if I were you, I would try to work one of these, or maybe work this problem over again and then come back and watch. I think you're going to need to watch this video multiple times, 2, 3 at least, to understand this process. Okay.